Hello, I have a paper 3 predicted paper in front of me. I'm going to be going through the solutions now. This is for the higher tier GCSE maths exam. Okay, there are 22 questions in this paper, so I'm not going to waste any time. So question 1, solve the inequality. 2 bracket 3x minus 1 is less than 4x plus 8. I'm just going to treat it like a normal equation. I'm going to expand that bracket. 2 times 3x. I'm going to move all my x's to one side and everything else to the other. 6x minus 4x is 2x, and that is less than 10 if we add 2 to both sides. Both terms are divisible by 2, so x is less than 5. The only difference with inequalities is that we get a range of values for our x rather than just one. Write these numbers in order of size, starting with the smallest. So 2 root 5, 9 to the power of a third, and 123 over 57. They're all in different forms. We can't easily compare them, so let's put them in the same form. 0.16. From smallest to largest, 2 is the smallest. Got the original price of the laptop before the discount. So if we call the original price x, if we say, okay, so times by 0.85, and that is equal to the sale price of 612. We can now rearrange for x, rearrange for our original price, that's 612 over 0.85. Calculate a question, 612 over 0.85, and that gives us 720. So the original question 4, here are the first 5 terms of a sequence, 2, 6, 12, 20, and 30. Find the next term. So we have a difference here of 4. The next difference is 6, then 8, and then 10. Find the next term. So what does the difference go up in? Well, that's plus 2, and that's plus 2. So we can assume that the next difference is plus 2. 10 add 2 is going to give us 12. Next term is 30 add 12, 42. 42 for the next term. Part B says to find the nth term of all of our terms in the sequence is changing each time. Then it's going to be a quadratic sequence, right? So quadratic nth term, we have an squared plus bn plus c. So we're definitely going to be having an n squared, but what is the a term? Well, 2a is equal to the difference of the difference. So 2a is, so we have the first term, the second term, third, fourth, and fifth, which are 30. And then I'm going to write my n squared term under here. So n is here, so 1 squared is 1, 2 squared is 4, 3 squared is 9, and then we have 16 and 25. Now if we subtract these, if we subtract the n squared from the original sequence, we're left with 1, 2, 12 take away 9 is 3, 20 take away 16, 4, and 30 take away 25 is 5. What are we left with? Well, we're actually just left with n. So 1 times 1 is 1, add 1 is 2. Correct. 2 times 2 is 4, add 2. Factorize this, we can take an n out of both terms, and we're left with n plus 1. Okay, so the nth term of the sequence is n bracket n plus 1. Okay. Question 5, here is an equation. 3x squared minus 11x plus 6, factorize it fully. When we see a quadratic, we're inclined to just take factors of the c term, this plus 6, that add to make the minus 11. But we have a coefficient on the x squared, we have an a term. When we do that, we do a times c. This is ax squared plus bx plus c. A times c, 6, 12, 18. Now we're looking for factors of 18 that add to make minus 11. So we have 1 and 18, 2 and 9, and we're trying to make a positive, right? We've got a positive c term, so both of our factors have to be positive, or they both have to be negative. Minus 2 and minus 9, minus 2 times minus 9 is positive 18, but minus 9 plus minus 2 is minus 11. So I'm going with these factors. Now we rewrite the entire equation, but we separate our x term, our minus 9x, minus 2x, plus 6. We just separated that middle term, right? And I like to just draw a little line down the center. And now we factorize, take a 2 out. Okay? And inside, if we take a minus 2, this term becomes positive and we're left with x minus 3. Notice how the brackets are the same. Now the way that we write our new brackets, the way we factorize this quadratic with a coefficient, is the first, well, either bracket is what is in the bracket that, right, adding together. Now these are multiplied, right? So we have 3x and we have a minus 2 on the outside. So 3x add minus 2 leaves us with 3x minus 2. We can expand. This is our original equation here, which we know adds to. Factorize fully. I'll just highlight the answer here. When x plus 6 is equal to 0. So we're solving the equation now. We factorize the equation, now we're going to solve it. It's equal to 0. This 0 is y. So when y is 0, that is the x-axis. So we're looking for the points that the curve of this equation crosses the x-axis. That's what solving an equation is, right? We've already factorized it, so we know that these two brackets are equal to 0 as well, because the equation is. So x minus 3, 3x minus 2 is equal to 0 number, right? If we knew what x was, we could substitute it in and get a number inside of each of these brackets. If we're multiplying two numbers and the answer is 0, then at least one of the numbers is 0, or both of them 3 to both sides, x is 3. 3x minus 2 is 0. Adding 2 to both sides, we get 3x is 2. Dividing by 3 both sides, we get 0. Well, x is 3, or x is 2 over 3. Okay? 6. A spinner has 3 red, 2 blue, and 5 green sections. James spins the spinner twice. Work out the probability of spinning 2 greens in a row. So, the probabilities, that one of the is the one that we're interested in divided by the total, right? So we have 3 red, 2 blue. What are we interested in though? We're interested in green. There are 5 greens, so the probability of getting a green in 2. Probability of getting 2 greens in a row, well, we just multiply the probabilities, right? So 1/2 times by 1/2 gives us 1/4. Probability of getting 2 greens is 1 in 4, or 0.25, or 25%. Work out the probability he gets a red and then a blue. It is 2 over 10. So, nicer numbers. That is 3 over 15. Question 7. Simplify 10x y squared over 5xy. Focusing on the numbers to begin with, 10 over 5 gives us 2. The x's cancel, x to the 1 divided by x to the 1. 1 take away 1, you know, laws of indices. Y to the 2, take away y to the 1. 1 take away, 2 take away 1. That becomes a 1. So the answer is just 2y. Okay. Solve 4p to the power of a. So to the power of a half is the same as square rooting. So if we square the entire, if we square both sides, so, well, if I show you 4p raised to a half, but then if we raise that entire thing by 2 to the power of 2 and raise 6 to the power of a 2, so we've squared both sides, we know that these two powers are going to multiply. A power raised by a power, they multiply with just 4p. 6 times 6 is 36. 36 over 4. 36, yep. Okay, question 8. The line L has an equation, the equation 4y is equal to 2x plus 6. Find the gradient. Well, when we have an equation y equals mx plus c, when we have 1y, the coefficient of x is the gradient, right? So if we divide everything by 4, y equals to 2 over 4x, or 1/2 x, plus 6 over 4. We'll leave it as 3 over 2. So our gradient of a parallel line passing through the coordinate 0, 0, 4. A parallel line parallel lines have the same gradient. They travel in the same direction infinitely and never cross because they have the same gradient. So our m is 1/2. We're given an x coordinate and a y coordinate. Half x minus 0. So y equals 2 1/2 x, and I'm going to add 4 both sides, plus 4. Okay? Y equals 2 1/2 x plus 5y all over y. If I multiply both sides by y, I get y squared equals 2. Now I could divide by 2, I could expand. Let's divide by 2. Y squared over 2 equals to 3x plus 5y. I'm going to move the 5y to the other side, but I'm going to write it like this. 3x equals 2. That 3 is going to multiply on the bottom with this 2. So we're going to get y squared over 6 minus 5y over 3. Okay, so x equals 2, y squared over 6. Let's multiply the second fraction by 2 over 2, and then we get y squared minus 10y all over 6, right? One fraction. Question 10. ABC is a triangle. M lies on BC such that BM is 4/5 of BC. Express these vectors in terms of x and y. B to C, we're going to go backwards to A and then along the 3y to C. So we're going backwards on the on the 4x, minus 4x, and then we're going in the right direction on 3y. So B to C is 3y minus 4x. A to M. BC is 3y minus 4x. So we're going to go from A to B and then B to M to get to A, from A to M. So we make that look nicer. 4x plus 12 over 5 minus 6 of x plus 12 fifths y. 4 over 5 x plus 12 over 5 y. Okay, M to B. So we need to get from M, so that means that M to C, down the 3y in the opposite direction, and then up the 4x. So M to C, 3y minus 4x. So we can do M to C is 3 over 5y minus 4 over 5x. And we're going to subtract 3y and add on 4x. So 4x, take away, and then we're adding on the MC, plus 3 over 5y minus 4 over 5x. This gives us 1/5 x and minus, if this is over 5, that's 15, 12 over 5 y. 1 over 5x minus 12 over 5 y. Okay. Question 11. Dave is timing how quickly swimmers can compete 50-meter lengths at his local leisure centre. His results are shown in the table below. So we know that there's a frequency of, if we add them all up, we have a calculator, 7. Okay, so the average or the mean is ranges. We can add them together and divide by 2. So 22.5. we have 27.5, 80. Okay. Now we need to do another column, frequency times by the midpoint, because there are 7. The midpoint is like the average of the range, but there are 7 in that range. So we're going to do 7 times 22. 20 times 27.5, 550. 44 times 35, 1,540, and then 19 times 50, and 10 times 80. Okay, so 950 and 800. Now, adding these together gives us our total, as if we were adding all of the data points up for the mean. 157.5 plus 550 plus 1,540 plus 950 plus 800. We get 3997.5. 3997.5. I'm going to divide that by 100, and we get 39.975. So we're rounding to the nearest integer, so we're looking at the first decimal point. That's going to round up. We get 30, that rounds to 0, that rounds to the 4, 40 seconds. Okay. The value of a car depreciates by 12% per year. The current value is £14,000. Work out the value for 3 years. Reducing by 12%, the same as multiplying by 0.88 times by 0.88, and for 3 years we're going to put a power of 3 on that. The power of 3, 608. After 3 years, that is £9,540. The job is going to take 20 person hours regardless. If the time changes or like the people change, right? So 8 people, we want to work out how many hours or how long it's going to take for this job to be completed. So we can work out x, the number of hours, by dividing both sides by 8. 20 over 8. 8 goes into 20 twice with a remainder of 4. That's 2.5. Reduce if we have more workers working on the job, right? Question 14. Oh, this is the centre, then these are both radii. Find the area of the shaded segment. So we have a sector of a circle. We can find the sector of a circle by dividing the angle by 360, area of a circle, but divided by 360 times by the angle, yeah. And then we have a equilateral, well, a isosceles triangle. So the area of a triangle is a half AB sine C, so we can combine all of that. Pi r squared gives us the area of the entire circle. We have 56 degrees of it though. 56 over 360 pi r squared will give us the entire area. We don't want the entire area, we want to get rid of the area of this triangle. Subtracting a half AB sine C. If A and B are the same length, because they're both a radius, then it's just a half r squared sine C. The angle C is in between AB, which is r, right? So I can substitute in all my numbers. 56 over 360 pi, and then r is 18, squaring that. Okay, I can plug that straight into my calculator. 56 over 3, 18 squared, sine 4.032 to 3 significant figures is 24.0 centimeters squared. Work out the square root of the tan of 18 plus the cos of 27 all over Steps. Calculate a question, make sure you write all the figures on the calculator display. Tan of 18. Add the cosine of 2.4625625. Then 5, it rounds down. Answer is 2.46. Okay. Question 16. An aircraft travels at a speed of 864 kilometers per hour, and we need to convert this into meters per second. Don't look at the number to begin with. Let's just work with the units. We have a kilometer per hour, and we need to get to meters per second. Kilometer, that's 1,000 meters. So we have the minutes. So we have 1,000 meters over 60 minutes. Now, 60 minutes is, there's 60 seconds in a minute. So we're going to multiply that by 60 again. So we have 1,000 over 60 times 60 meters per second now. We can reduce that. 1,000 over 3,600. Zeros cancel, zeros cancel. We have 10 over 36. Both divisible by 2. We have 5 over 18. Okay. 5 over 18 meters per second. So now we can just take our value of 864, multiply it by 5 over 18. 864 times 5 over 18. That gives me an answer. Ali is taking part in a cycling challenge. He cycles either Trail X or Trail Y during his training sessions. In April, he cycles Trail X 9 times and Trail Y 5 times. Trail Y is 8 miles longer than Trail X, and altogether he cycles 800, which is 20% longer than Trail Y. Calculate the length of Trail Z. Okay, call it X. Trail Y 5 times, let's call that Y. Okay, and Y, that adds to 89. But we know that Y is 8 miles longer than Trail X, so we have Y in terms of X. We can substitute in this Y, so it's all in terms of X. So we have 9X in terms of X, and that's equal to 89. So 9X add 5X plus 40 equals to 89. We have 14X equals to 49. So 49 is 8 miles longer than Trail X. Then Y is 3.5 plus 8. Now, Trail Z is 20% longer than Trail Y. 20% increase, 20% longer. That's the same as doing 1.2 times the number, right? So 20% longer than Trail Y, we have 11.5 times by 1.2. That is 13.49, but I trust it, right? Question 18, here is a rectangle. The length is 6 centimeters longer, so it's x plus 6, right? 4 of these rectangles are arranged to form the 8-sided shape shown. The perimeter of the 8-sided shape is 76 centimeters, so we need to work out the area of the shape. I'm just going to substitute in, put these values everywhere on the diagram. That's x, that's x, that's x, and that's x. And then this is going to be x plus 6, x minus the width, right? Minus x. X plus 6 here, x plus 6 here, and x plus 6 here. Now I can add all of this up. I have 1x, 5x, 6x, 7x, 8x. I have 8 x's, and now I have 6, 12, 18, 24, 30. 8x plus 30 is our expression for the perimeter of this shape. But we were given a number. The perimeter of the shape is 76 centimeters. 76. 46 over 8 is 5.75 centimeters. Okay. Work out the area of this shape. We have 1, 2, 3, 4 of these rectangles. So we're going to do x times, we know that the area of 1 So writing that expression, x times by x plus 6, we have 5.75. Area of 1 I got to be 67.5625 centimeters squared. Well, we have by 67.5625. Keeping all my decimals to make my answer more accurate. Times that by 4 gives 270 to 270. But I'll leave the decimal in. Can't hurt, right? Never asked to. X cubed minus 4x over 3x minus 6, all divided by x squared minus x over 5. We need to write it in the form ax plus b over cx plus d. A, b, c, and d are integers. We never divide. We're gonna, what is it? KFC, right? Keep this fraction, we're gonna change this fraction and then flip this sign. I feel like it's change and flip. Okay, so rewriting that as x cubed minus 4x over 3x minus 6, and I'm multiplying by 5 over x squared minus x now. Now, I'm going to make it a bit simpler. I'm going to rewrite it. I'm going to take an x out of, because in that first fraction we can take an x out of both of those terms on the top. So that leaves me with x squared minus 4 on the inside. You may notice something interesting about that. And then I can divide by, I can take a 3 out of both of those terms, and that leaves me with x minus 2. Okay. X squared minus 4, if I bring that up here, difference between them, this is the difference of two squares. So this can be written as x plus 2, x plus 2, x plus 2, x minus 2. Okay, so I'm going to rewrite this expression here. X plus 2, x minus 2. And then 5 over, we could take an x out of there as well. X minus 2. Right? Now in this first fraction, those two brackets cancel. So we can rewrite the entire thing times the bottom. What are we left with? 5 times, well, I'll just on the bottom. Okay. Doesn't quite look like what we're expecting, so I've just noticed we can divide these x's out 6. That is in the form that they were asking, so I'm going to leave it like that. So now we need to express 3 over x minus 1 plus 2x over x minus 2 minus 2 as a single fraction in its simplest form. When we're adding and subtracting fractions, we need the denominator to be the same. Right now they're not. Let me ignore this minus 2 for now. I have 1 term, 2 term, and 3 term, which I will come back to. Focusing on 1 and 2 though, we're adding them together. So for fraction 1, term 1, we have 3 over x minus 1. And I want it to have a common denominator. So I'm going to multiply the denominator by x minus 2. But if I just multiplied by the denominator by x minus 2, then the entire fraction 3 over x minus 1 would be x minus 2 times smaller. We're not trying to change the fraction, we're just trying to change the form of it, the way it looks. So I'm going to multiply the denominator, 1. Anything divided by itself is 1. X minus 2 over x minus 2 is 1. That gives me 3 bracket x minus 2 on the top, and x minus 1, x minus 2 on the bottom. I'm going to do the same thing with the second, x minus 1. Remember, x minus 1 over x minus 1 is x minus 1 over x minus 1, x minus 2. Same denominator. Those fractions can now be added together. Now let's reveal the third one. We have minus 2. So minus 2 isn't a fraction. But we can turn anything, any term, into a fraction if we just divide it by 1. Anything divided by 1 is itself. But I want this minus 2 to have the same denominator. So I'm going to multiply by that entire denominator. X minus 1, x minus 2. x minus 2 over x. So, the first one, add the second one, subtract the third one. We have 3x minus 2 plus 2x x minus 1. Take away all over x minus 1, x minus 2. Okay, I'm going to expand the top, collect my like terms, and then simplify the entire thing. 2x squared minus 2x. Let me expand those brackets first, actually. X squared, so I'm doing x minus 1, I'm doing this. X squared minus 3x plus 2. Okay. All over x minus 1, x minus 2. Again, running out of space. Like terms, so 3x minus 6 plus 2x squared minus 2x minus 2x squared plus 6x minus 4. I'm just going to rewrite that here without the denominator. The 2x squared cancel. 3x minus 2, x minus 2. Okay, that's the simplest form as far as I can see. Question 20. The diagram shows a right-angled triangle ABC with the right angle at point C. AB is 14 centimeters correct for the length of side AC. So if AB, 14 centimeters, is correct to the nearest centimeter, then it could be 13.5 centimeters. But it could also be 14.5 to the nearest decimal point. That could be 8.4, and that can go up to 8.5499. Okay, so we're going to check for the hypotenuse and the upper bound for the adjacent side here, because we're taking a lower number and then subtracting a larger number from it. A squared equals b squared plus c squared. We want b, square root of a squared minus c squared. Subbing in our values, we get the square root of a squared, which we're going to take as 13.5, take away 8.5499 all squared. In the calculator that comes out 10.4474. Show value working clearly. Lower bound. We got a number with 1 decimal point, so I'm going to round it to 1 decimal point as well. 10.4. Okay. Question 21. A water tank is a cuboid measuring a height of half of a meter, width of 1.2 meters, and a length of 0.75 meters. Work out the volume cubed is 1.2 times by 0.75 times by 0.5. 1.2 times 0.75 times 0.5. That is 0.45 cubic meters. Now, 1 cubic meter is 1,000 liters. 1 meter cubed is 1,000 liters. So we've gone from, to get from 1 to 0.4. Another way of seeing it is, how do we get from meters cubed to, okay, so I'm multiplying the 1,000 by 0.45, but you can multiply the 0.45 by 1,000 as well, same thing. That's going to give us 450 liters. Full times it by 0.6, 0.6 times by, okay. Now water flows into the tank at a rate of 1.5 litres per second. So how long will it take to fill the rest? Give your answer in minutes. There are currently 270 litres in the tank with a capacity 180 litres. Okay. Now the rate of something is the volume over time. We want the time over the rate. We have 180 litres over 1.5. And the rate is in seconds, so we're going to get, and this is in seconds. We want the answer in minutes. There are 60 seconds in a minute. 120 over 60 is 2. So 2 minutes. To take, here's how long it will take students. 32 study maths, 28 study physics, 25 study chemistry, 12 study both maths and physics, 10 for maths and chemistry, 9 for physics and chemistry, and 5 study all 3. We need to fill in a Venn diagram to represent this information. But first we need to do some maths, because this 32 that studies maths is taking into account the ones that study physics and chemistry and all 3 as well. So we get maths and chemistry, physics and chemistry only is 4. We can do the same thing, maths and chemistry only. 10 take 5 is 5. Maths and physics only. 12 take 5 is 7. Okay. So we can do 25 for chemistry only, the 5 that study maths as well, and take the 4 that study physics as well. 14, that leaves us with 11 for students study chemistry alone. Same thing for physics alone. 28 take 5. So that's is that take 7, take 5. 17, 5, is that 50? So for study all 3, right in the centre we have 5. Maths 15, physics 12, chemistry 11. 15, 12 and 11. And now what about the cross section? So maths and physics 7, maths and chemistry 5, physics and 5 and 4. Now what do these add up to? If we add all of those together, we get 15, add 12, add 11, add 5, add 5, add 4, add 7, 59. We get all of those added to 59, but we're told that there is a group of 60 students. Seems a bit silly writing this, but 60 minus 59 is 1. So there is 1 student left. Okay. 1 student is chosen at random. Find the probability that the student studies maths but not chemistry. So what are the scenarios where a student can study maths but not chemistry? Let's highlight them. These people study maths but not chemistry. These people study maths but not chemistry, as well as physics. 7. So we have 15 plus 7 over 60. 30. Okay. End of paper. Hope you found that okay. I recommend using this for your revision, going through all the questions. Like I said, don't just follow me blind.